Alright, so tonight wanted to take a look at what is ODBC. Most of us have probably at some point used a database, either within applications we've built, to run analytical queries, to connect Excel to a data source, any number of things. There's a variety of different ways to go about that. One of the more popular, especially if you're working with applications from different vendors, is ODBC. The interesting part is a lot of people only know of ODBC from the connection perspective. Like, this is a thing that I put a string in and suddenly I can talk to the database. We made use of PyODBC and AIODBC at Humana while I was there. And at one point, my manager, Brad, who actually spent time working at Sybase for about 16 years, proposed that an interesting talk would be, what is ODBC? Because most people use it and don't really know what it is, which is kind of how an abstraction should work if it's working well, but when it doesn't, not so fun. So to kind of get started, ODBC stands for Open Database Connectivity. It's a specification for a database API to create a standard way for applications to interact with a variety of databases. Another part of it is it's independent of platform, language, or the actual backend database. So while Microsoft, IBM, and some others were instrumental in kind of the original spec, and Microsoft appears to be kind of the driving force behind it still, there's nothing specific to Windows or a language or anything about it. So to kind of just wanted to show this real quick in relationship to talking about it being independent of language. If you just search ODBC on GitHub, as you can see, the languages on the left there. There's probably even more than that, just the standard return shows the top 10 there. You can see a variety of languages in use. You can even see that kind of in the search as well. And then this is a Python example of using ODBC within a Python application. So when talking about ODBC, today it can be kind of maybe taken for granted why we would need something like this. A lot of times at the application level, maybe you've got a library specific to your database, or maybe a vendor's made a driver available or some way for you to connect to your system. But historically, and even today, there's a continued explosion in databases available. So, you know, we started seeing the initial database systems rolling out in the 1960s. And even today, you know, while kind of their operations and how they work internally may have changed for different platforms, we continue to see new ones pretty consistently. So there's CockroachDB, Hive, and various different databases that span the relational model to the document to various other NoSQL models that actually provide ODBC and a driver for you to be able to interact with it in a fairly agnostic way. Part of the pain historically and even today is that databases have their own wire protocols. And so when you talk to a database, you're probably thinking about the query that you've written. Select whatever from this table, where, group by, order by, having, whatever. The thing about that is when that gets sent over, there's all these steps that have taken place ahead of time. So handshakes to connect, to share information, to set up attributes of that connection, and all of those have to happen in a specific order. And that's kind of what that wire protocol is defining, is the sequence of bytes that need to be transferred to actually talk with the database. And historically, most vendors published their own, created their own wire protocols, and these weren't in the open. So if you didn't have a driver for whatever you were trying to do, and they didn't provide that to you, you were out of luck. There was nothing you could do unless you want to spend some time reverse engineering some fairly complicated protocols there. Now, today, if this is something that's interesting that you want to learn about, Postgres has their protocol out in the open. Postgres is an open source database project. There's actually other databases that have started to use that because re-implementing a wired protocol is kind of timely and expensive. And so MariaDBs is going to be out there as well. There's quite a few now. Additionally, today we kind of take things like Excel for granted or Tableau or think of all these different items. But when ODBC was being spec'd out, the advent of the personal computer was kind of happening. That being on people's desk was kind of a new thing. And so everybody was wanting to get these connected up to data stores so that they could enable people throughout their organizations to interact with that data. And then finally, if I understand kind of the basics of ODBC, whether I'm writing C#, Python, C, PHP, pick a language, Go, I have a general idea of kind of how this is going to work. You know, I'm going to create a connection, I'm going to have a cursor, I'm going to pass it my query, I'm going to tell it how to fetch the results, I'm going to get the results back and do something with those. And so there's an order of events and operations that are fairly reliable across languages.
Alex,
yeah.
Just curious before you move on, and maybe we'll get to this, is ODBC a wire protocol, or does ODBC translate what you want to do into the database in wire protocol?
Yeah, so we'll get to that.
Okay.
ODBC is an API, and we'll here in a second touch on the difference between an API and a protocol, because that can be, it can be a little bit up for debate depending on the layer, and it's also kind of confusing. But so I found this online. That was pretty neat. It's in the notes, but this is kind of a genealogy history of databases. And so if you're wondering like why we need ODBC, imagine everybody specifying their own driver or connectivity protocol that you have to learn to talk to. It's not uncommon anymore to have 5, 10 plus different database data storage systems in what you're working on. So kind of that illustrates part of it. And then when you think about programming languages, like zooming in on this gets way too small, but O'Reilly kind of published a lineage of languages also. This only goes through 04, but as you can see, an explosion there. So having a protocol like this, because databases are so central to a lot of the work that we do, it makes a lot of sense. All right, so Randy, you asked, API or protocol. So part of this can be, the reason I say part of this feels like it can be up for debate is it kind of depends on which layer of abstraction you're working at in the stack, whether something's an API or a protocol. Some people will say that, but kind of the key difference when I was digging into this and trying to separate the two, an API describes valid functionality. So if you think about like the request library is exposing valid functionality for HTTP verbs, sessions, things like that, right? It's giving you that functionality, but behind the scenes what the protocol is doing is defining the sequence of operations that happen. So when you make that request, you know, you've got TCP, UDP, certain packets have to be in certain orders and things have to happen in a given sequence of bytes for that to actually work. The protocol is defining that byte sequence. The API is exposing the world of functionality that you can use. Any questions about that? All right. And then a brief history of ODBC versions. And I'm bringing this up because, you know, it's been around for quite a while. And so it's 2019. This started in 1992. If you think about when personal computers started to get more common and prevalent, I wasn't in the workforce, and so you can kind of like, things have changed a lot very quickly, very rapidly. And so ODBC kind of tried to get out in front of a lot of this and create a common standard that everybody could kind of spec to for an API. And then you can kind of see the development as it progresses. There is a GitHub repo for the 4.0, and I think the last update was a few months back. So kind of keep, if this interests you, that's a good place to keep an eye on. You can also see that like development seems to be 10 plus years in between major things. Well, not major, minor up there, and then we have now. So related to this is also why historically when people talk about cursors or ODBC, there's a common feeling that it's going to be slow. 1.0 and 2.0, that was actually fairly true. The way cursors and various pieces were implemented, it was much less, it did not perform near as well as a driver going straight against a wire protocol. In the 3.x series, a lot of the ODBC interfaces started to kind of, there's a bit of a pass-through going on there, and as well as various threading settings, cursor settings, and whatnot help speed that up, and you can actually get pretty good performance today. So, and I should have said this at the beginning, kind of briefing you all on this, and then we'll actually dig in at the terminal in different places and look at how this works on a NIC system and talk about Windows as well. So the way it works is you have your application. Pick your language, you're writing your application, or maybe you're not actually writing an application, maybe you've bought something, some type of BI tool or something that wants to talk to a database. So to do that, you're going to bring in an ODBC library. The language does need to or the application needs to have that ODBC interconnect that's going to talk to a driver manager. This driver manager does a ton of work, and basically it's keeping up with all the drivers and data sources that are available on your system in the settings for each one as you call out to it, routing that, making sure the attributes line up, passing the data back and forth. And because you can have, not only does ODBC 3.x support concurrency within the driver and application, so you can have multiple requests within a single process, but you can also access multiple databases, if you were to write your code this way, multiple different databases in parallel across processes, and the driver manager is going to be able to support that. And it's going to take those incoming requests, route them to the appropriate data source and driver, and control that flow of data between your application and the driver. So after the driver manager, you have the actual driver. This is going to come from a third party or from the database vendor. So Microsoft, Oracle, IBM, Postgres, a lot of the major databases or people using their protocols are going to provide you a driver. There are companies that sell drivers. I've never used one. People do, there's whole businesses around it. So they're offering, most of what I saw claimed to offer, A, support, and then B, different performance characteristics. So there's a variety of drivers out there, and those drivers are what actually takes your query, once it gets there, and knows the wire protocol implementation for the database, and does that sequence of communication events to send the query over, let the database respond back, and route that back up through this into your application. All right, so how do you use it? The first thing you're going to need to do, if you're on a Linux or any Nix box, is install a driver manager. Today, your best bet is Unix ODBC. Historically, there have been some other driver managers like iODBC, but Those have not been maintained as much as Unix ODBC has. In fact, active maintenance seems to have dropped off a few years back. If you're on a Windows system, this is in there out of the box. So if you go to search, you'll type in ODBC space data space sources, and you're going to see a 32-bit option and a 64-bit option. And click that, you're going to have a dialog prompt pop up. It's a nice GUI to interact with. So once you have a driver manager, you're going to need to get the driver. Google's your friend, database name, ODBC driver, download. Install that driver, and then in Windows or Unix, you're going to configure it, as well as potentially set up a DSN. We'll look at what DSNs are. If you want to follow along, I should have shared that at the beginning. This is on GitLab, but you can kind of check it out after. We're going to look at this just because it's what I'm running, setting it up, and then we'll check out how to use it. All right, so before I jump too far into the terminal, any questions about ODBC?
I had a question.
Yeah.
You on the diagram, you had multiple drivers talking to multiple databases, and you said you could have an application that does that. As far as like the features that are supported across different databases, or some might be unique to a specific database.
Yep.
How much support is there? How much, when I'm writing the SQL in my application, do I need to know which database I'm actually hitting versus it's just an ODBC driver?
Yep. So ODBC specifies the API to kind of interact with the database, right? But you're still going to use SQL traditionally. I mean, if you're using, there's some databases that skew from that, right? But like if you're talking to a Microsoft SQL server, that's going to be T-SQL. If you're talking to a Postgres database, that would be the P-SQL, Oracle, PL-SQL. And so it's going to take that statement and send that over to the database.
So the driver doesn't do anything with the query itself?
Right, yep. The driver, well, it does, but what it's doing is translating the query to get it into the database where the engine runs it, right?
Right.
So that driver knows how to take that query along with everything else the database expects and to create that protocol sequence to basically say like, hey, we've got a connection open, I'm sending in a statement, or I'm sending in a stored product.
Does it translation to the wire protocol? Or
the driver does.
Okay.
Yep. Yep. And it might be easier, let me...
And then when the database receives it, essentially it would be the exact same as if a native driver were used.
Yes. Okay. Yep. And the part here, for instance, is cross-language, cross-platform. You know, your team might develop in a Linux and Mac environment, and you know, Unix ODBC is going to work across there. You might have parts of your application in different languages, and maybe you've got a lot of services, right? So microservices are more and more popular today. Not getting into that, and so maybe you have one in Go and one in Python and one in C++ or something, right? Those can all use the same ODBC driver. You don't have to have a Go driver, a Python driver, a C++ driver that knows how to talk to your application and talk to the database.
Okay.
So, and we'll kind of, we'll step through a little bit of it and maybe that'll help. But yeah, the driver is basically, it knows how to actually get the data off of your box over to the database and then back from the database to the driver manager.
Okay.
By the way, side note, connection strings dot, my screen's too short, .com will probably save you some pain at some point in your life if you're interacting with ODBC, because as you can see, it's got quite a list of databases and their options. As for instance, SQL Server, the connection string actually provides a variety of configuration options. All right. Any other questions before I jump in here?
Hey, Alex, just a reminder, you're not actually sharing. When you switch to the browser, it's not sharing your browser. Oh, that's
Yeah, because that's what I get. So let's switch there. All right, so to kind of illustrate a little bit about this, so we're kind of in the shell, and I'm going to need to, is that readable? All right, so kind of like I mentioned before, on a Linux or Mac box, you're going to want to install Unix ODBC, whether that's through Brew, apt, yum, or something else. On Windows, you're good to go. With that installed, you're going to get a tool called ODBC Inst. And what this does is this is the kind of installer and uninstaller. This will help you manage those data source connections. Because within ODBC, there's two important files. There's odbcinst.ini and odbc.ini. ODBC, and this is all part of the spec, by the way. This wasn't just fun INI files people created. odbcinst.ini is where you define driver information, so where that database driver is on your system. odbc.ini is where you configure data source information. And we'll look at the difference there, but again, you could have multiple connections using the same type of driver with different settings. So, handy command to keep in mind when doing this is odbc-inst-j, because what this is going to do is show you your version information, but more importantly, it's going to show you where the ODBC driver manager is looking for your drivers and your data sources, because if these are not configured, you're going to get a lot of weird connection errors. One thing to call out here, ODBC supports the idea of system data sources and user data sources. So system data sources are available to any process running on that system. User data sources are local to that user and the processes for that user. All right. And then if we want to look at those, so this is our driver information. So I've set up SQL Server and Postgres. They both have Docker images and just kind of learned that I'm more familiar with those, so we set those up for this. So basically, the long and short of this is you've got a description and a driver. That driver needs to link to where the actual database driver is. Locate's a handy command if you don't know where it installs when you unpack something. But so basically your driver is going to need to point to that, and then you'll see some things like debug, com, usage count. So you can do a little bit of rate limiting in here. If you're getting errors, this is where you can set your debug level. This is also, you can put a trace command in here and tell it to output to a file for trace. That's incredibly useful when things are getting weird and you just really don't know what's going on. And for instance, if you're going to open up a ticket on, let's say, the free TDS GitHub page, they're going to ask you for a trace log, because debugging database issues or connectivity issues without a trace log is close to impossible. So far we've installed our driver manager. We have our driver file odbc-inst.ini set up. And then for this, I've set up just my user to have data source connections. And this is what they look like. So Postgres, you can see the driver and what it equals. This is going to be looking out to my ODBC inst file. So Postgres here is Postgres there. Description, server, port, username, password. You can put those in there. You shouldn't, because there's no encryption around these files. So don't include those in there. And then you can specify the database. Notice the fun part. While ODBC defines an API specification, there's always flexibility within specs. And so every driver can bring its own connection attributes. So Postgres, port's separate. The MS SQL data source, port is part of the server separated by a comma. And if you want to specify how the protocol you're connecting with, so TCP versus name pipes or something like that, that actually goes before the server name, comma, port. And so read the docs. To kind of point this out, I was a little bit mind blown when, please go away thing. I looked at this. There's a list of connection attributes for Microsoft ODBC, and I'm really not exaggerating. It's between 50 and 100 items. So you can configure these things way further than is normally done out of the box, which is actually really good if you know about it, but because ODBC gets fairly rote and easy to use, the more you use it, most of the time people just set up their connection string, acquire connection, open cursor, send my query, fetch results, life goes on. When it's slow, it's blamed on ODBC. When there's all kinds of like threading settings and process count settings and all kinds of different things that you can configure within your connection string or within this data source file that actually impact all that. So that's something to kind of really, I would suggest, like, if you're using ODBC with a given database, especially, you know, if 80% of your work is against a specific type of target, I mean, once you figure out the settings you really like for SQL Server, it doesn't matter where the host is, you can kind of replicate those across SQL servers. But you really can get a lot of benefits from correctly configuring this. The defaults are default, and they try to make the defaults good, but anytime you get into that tuning component, and I bring that up because before you kind of step into, let's say you're like, okay, we're in the database world, so we've got network I/O, we've got database I/O, we've got a lot of I/O-based weighting within our application potentially. You might be like, all right, let's reach out and pull in AIO ODBC for Python and start doing concurrency and process to get better performance. That may well be worth it. You might also be able to get a lot of performance out of configuring this data source connection correctly or better. All right, so with that, we can actually connect. All right, so on a on various Nix-based machines, you're going to get iSQL when you install Unix ODBC. And so if you type that, you'll kind of get the list of commands there. It's another command line utility. But the basic part is specify your data source name, so that's in the brackets in that odbc.ini file. User and password. One thing I'll call out, almost always use that -v. And the reason for that is, instead of guessing, let's just, yeah. So let's get rid of this. And I'll pass the username. And that's all it tells me. However, we can type in these types of things, and -v, verbosity, it'll just give you more information, especially if things aren't lining up in different files and whatnot. This is actually pretty good about telling you like, hey, I can't find this here, or they're just different components. So definitely keep that in mind. But all right, so with your data source configured, and real quick, just so everybody notices. So here, these are different, and that's why it was telling me, hey, I can't find that data source. That doesn't exist. All right, and then, but once you're connected, if you want, another thing to quickly call out, if you've connected to a data source, but you kind of want to verify that you're kind of in the same world, depending on your permissions, this may or may not work. Most databases have information schema tables. Oh. There we go. That you can kind of query and just kind of get a quick response from to make sure that you're good to go. But that's a quick CLI utility so that once you kind of think that things are working, you can kind of confirm that by connecting. And this has a lot of different options, ODBC calls, SQL Driver Connect, and whatnot. Okay, any questions from that part so far? Okay, so in that case, let's check out Python with ODBC. Like I mentioned, I'm going to use Postgres and MS SQL. So within Python, there's a few different ODBC libraries. So there's PyODBC, which is probably the most well supported in the sense of it's got lots of documentation. It's been around for a while. They've kind of been around long enough to find some of those edge cases where the ODBC spec and maybe the database itself don't line up 100% and work on those issues. There's also TurboDBC, which is a newer one that's interesting that implements async I/O and makes use of NumPy and Arrow kind of underneath to get some nice performance gains. And then there's a commercial one called MXODBC, and then finally PyPyODBC, which it's interesting how it markets itself. It markets itself, the difference between PyODBC and PyPyODBC is most of PyODBC is in C++ with Python wrapped around it, whereas PyPyODBC is a pure Python implementation. It's still making use of C types to call out to a set of header files that are the ODBC spec. So, I don't know, it kind of sort of is, but not all the way Python. So, up here you can kind of see, as Randy had mentioned before, we've pip installed PyODBC. And then you'll notice I'm connecting to SQL Server in the first block, and then Postgres in the second. You can do a lot of different options with PyODBC. Similar to talking about that data source file, you'll want to look at the API. There's a lot you can do with execute many, fetch all, fetch one, all kinds of different fetch and send method or functions. But what you can see is these blocks are pretty similar. So I don't care if I'm connecting to SQL Server, MariaDB, MySQL, Postgres, whatever. I'm going to start out, pyodbc.connect, give it my connection string. That connection string can be as simple as just a DSN if I have all the information in my DSN, or as I mentioned, that site, connectionstrings.com, check it out because you can put tons of stuff in here if you don't want to put it in that odbc.ini file. One other thing to comment on within ODBC is you are the master of your transactions. So when we're talking about a database, anytime you're doing work in there, whether it's a select, an insert, etc., you have the concept of transactions. ODBC can do auto-committing, so as each statement completes, it can be committing your transaction. but depending on your workload and the performance characteristics you're trying to achieve, you may not want that to happen, but kind of for simplicity's sake, I've turned it on here. And the reason I bring that up is if you don't commit and you run a lot of work and then you exit your application, that work never happened. So just kind of keep that in mind, you're the master of your transactions. So then the next thing after we have our connection is we create a cursor. And then from that cursor, we can actually execute our queries. You can call out to stored procedures, you can run query statements, you can do inserts. ODBC actually has a spec around how to do string interpolation of your query to insert values, and that's spec'd out in the specification so that no matter which database, the syntax around that is going to be the same. As far as the string interpolation, not the actual insert command syntax, that's going to be specific to your database still. Okay. Any questions so far yet? All right, so looking back at this, we have our application in Python. PyODBC is exposing that ODBC API for us in Python. That knows how to talk to our driver manager. If you want kind of the gritty details, there's an ODBC header file, the SQL header file, set of header files that are kind of the default across platforms. Those define a SQL driver connect function. That function takes your connection string and communicates with the driver manager. The driver manager takes that connection string and then looks for a data source. If it finds it, it continues to look for the driver for that data source, and wherever that driver is pointing, so we've hit the odbc.ini file. Now it's going to check the odbc inst file for the driver location. It's going to load up that driver, pass your query or whatever you submitted through that. So it's always going to be a query you're submitting, but the type of query, I guess. And so you're passing that through. That now goes to the driver. The driver knows how to take that and based on the statement to set up the protocol bytes that are expected, so the TCP bytes and everything, or if you're using named pipes, because that's the thing. Most of us are used to thinking about this going over a network, but most of these databases support TCP. They also support named pipes and other protocol methods. So based on your protocol configuration, the driver is going to say, okay, this is the protocol, this is the sequence of bytes the database expects, here's the statement within those bytes and packets, ship that over, and then it's going to listen, and the database is going to take your query, run it through the parsing and execution engines, and then send back some type of response. I say some type because you might not have written a select statement, so you might just get a hack of OK, basically, or good to go. That's going to pass back to the driver. We're going to go back up through that stack. Finally, the ODBC API is going to get information from the driver and pass that back into your application where you interact with it again. So one of the things I did, and again, I'll share this out so that everybody can check it out, is try to follow this through for a little bit. So here's where things kind of, if you're going to use this, especially if you're going to be the one debugging it or thinking about these things, something to keep in mind. And this is kind of true, I think, of probably most database interactions in a language is at some point you're going to hit a lower level language than Python. Depending on if you have errors that you're trying to trace through the stack. And the reason I bring that up is with PyODBC, it's binding to C++ and C files. And so eventually we exit Python and we're in kind of the C world. Because of that, PDB or other just Python debuggers don't know how to translate that code or to even look into it. And so on Linux machines, you can make use of LLDB or GDB to kind of look into those. And so that's what I'm doing here. The other thing is for PyODBC or any kind of C extension application, you also are probably going to need to recompile that instead of using it from pip. So I've got notes in the outline for this for that. Because Python, by default, PDB knows how to look at that and interpret it. Python, it's got all that built in, and it doesn't strip that out for like a production shipping unless there's a way to do it, but most people don't. C and C++, on the other hand, debug symbols are removed whenever you compile by default for various performance and optimization reasons, but you need those if you're actually going to debug C or C++. So PyODBC, there's a command out here. So when you go to install it, you'll run setup.py. Randy kind of briefly mentioned setup.py earlier and do a build. You're going to pass in the compiler arguments to get those debug flags. All right, so in here we're in LLDB. One of the things we need to do is set up breakpoints. If you've used breakpoints in Visual Studio or PyCharm or various other systems, kind of same idea, you're just specifying these on a command line. And so these are some of the interesting ones to check out, just because they're kind of where these interactions are happening with that driver manager. Because remember, your application doesn't actually talk straight to the driver. It talks to the driver manager that knows how to talk to the driver.
Alex, is the driver manager a service or is it a library layer?
It's a library layer. All right, so we'll set a breakpoint, and we don't see it yet because we're not there. All right, so if you remember, this is kind of that Python file from before. So if we go through, we can see various steps. And right here, when we hit this PyODBC connect, we'll see everything suddenly looks a lot different. And went from PDB on the left there to LLDB. And so pretty much as soon as we call that connect function, we are into that C, C++ library that PyODBC wraps. HDBC's an interesting one. I've seen this a few times now. It stands, from my understanding, it's handle ODBC, because ODBC gets used a lot through these libraries. Anytime you see HDBC, it's actually speaking to the handler for your connection from what we're looking at here. Do I? Sorry. All right, so we'll go ahead and let that resume. And so basically, you can then see we step through all that. One interesting part, it's kind of like with PyODBC, if you actually want to go into the driver manager, you're going to have to compile it with debug flags. If you want to go into the driver, you're going to have to be able to get the driver and have it with debug flags. So these are all kind of things to keep in mind. Chances are you're not going to need to go that low. I just kind of wanted to highlight, like, there's a lot of layers here, a lot of places where things can be configured and set because used ODBC a lot. It's worked really well for me, but you can put settings all over the place. They can be in files, they can be in your application. The driver may or may not support different things depending on the year and the implementation. So just kind of looking at this, you can see that we got results back from SQL Server, and then we hit that cursor line again, or connection line again, so you can kind of see right up here. Oh, sorry. Connection new, and so this is hitting that Postgres connection. We're walking through it. If we did not get a successful handle, we would get an error here telling us what's up with that. And so you can kind of see our connection string has been translated into a byte type instead of a string, kind of normal when we're dealing with system level information. And we can see that our handles here, our return value is good, we've acquired a connection, and the object info. And you could disassemble all this, you could uninterpolate it, do all these things. Just kind of showing this to give you an idea that like all of this is possible. Most of the time you're going to be in Python. Make sure you're using the API right. Make sure that ODBC.ini, that ODBC.ins.ini is configured correctly. And if you do those three things, it's probably going to work really well for you. But from time to time, we're dealing with databases, a lot of abstraction and drivers, and things will go sideways, and maybe this will come in handy for you. So if we continue on, you'll see our connection was created. We executed our query. One interesting thing with PyODBC is you can actually get the column names for the tables that you're querying, so that's what you see first. And then down below that, you see the actual query return, and then PDB wraps back around. So, 1 second. So you can kind of see that columns right there. And that's supported across databases. That's part of the PyODBC API. And ODBC exposes that column information. So kind of jumping back in where we left off here. We've went through the various components. One thing I do want to touch on. So within Python, because we're at Python MeetUp, so we've got ODBC, which is the specification for database vendors, driver makers, and others that kind of defines that API for interaction. Within Python, we also have the DB API, so PEP 249, that defines how database libraries should expose their functionality. And this is actually independent of ODBC. So PEP 249, it's actually, I don't know, I thought it was interesting. But it goes through and talks about how all of these database objects should be exposed and work within Python. So if you transition from one library to another now, let me caveat, not ORMs, but like database libraries, you're going to see that they have a connect function, they have a cursor function, they have an execute many. A lot of these functions and methods and class objects are going to be similar, if not the same, at least to you, because of PEP 249 specifying how database APIs should be exposed. So that's kind of neat. All right, so before we kind of talked about, there's ODBC, and then there's also alternatives. So, for instance, Postgres has PsychoPG2 or PsycopPG2. Sorry, I always read that as PsychoPG. There's PyMS-SQL. I know that MySQL has its own native driver. Oracle publishes CX Oracle for Python. So you don't have to use ODBC. But what ODBC lets you do, kind of in the way that DB API makes it to where if you use various database packages, they should kind of look and interact the same. ODBC kind of does that for databases, whether you use MySQL, MySQL, Postgres, Mongo, whatever, because Mongo has an ODBC driver. That interaction should look the same to you as the user. The driver itself is going to be doing different stuff. So kind of among the advantages for ODBC is that consistent API. There's really good library support. It seems like most times when a new language pops up, ODBC pops up in it pretty quick. So I know Rust had ODBC pretty quick, Go already does. And sometimes multiple ODBC libraries because they try to do some different tricks there for performance. And then also, as new databases come along and as they want to make their functionality available, it creates a common target for those database developers to expose that functionality. Some of the disadvantages, one that you'll see, this isn't necessarily true of kind of if you're using like PsychoPG2 versus ODBC, is dynamic query overhead. So there is a concept of embedded SQL, specifically within C, C++, I haven't seen it anywhere else, where your statement can actually be compiled ahead of time, and the query engine go ahead and do all the optimization and parsing. And at compile time, you actually link in a library from that database vendor, and that SQL is basically like hot encoded, already ready to go. It goes straight against the execution engine instead of being parsed, because that's all already done. Whereas within most languages, you're passing a string that is your SQL statement, and that can be interpolated in different things, and it has to go against the optimizer engine and get evaluated. ODBC is complex. If you go out to, kind of got this in the reference links, but if you go look at the ODBC specification that Microsoft has online, which is interesting, but it's a thick read. If it was printed out as a book, I really wouldn't be surprised if it was well over 500 pages. So you've got this programmer's reference, all these different components, architecture, SQL and ODBC, access architecture, database architectures, and then even within here, if you look at the API reference, these are all the different references of what that API has to expose. And so you can see there's just a huge, and you can actually see these in PyODBC because it has C++ bindings to the SQL.h and ODBC.h header files to make use of all this. So it's really interesting. If you want to learn more about the actual spec and the architecture itself, this EasySoft link seemed to be one of the better ones, as well as the Unix ODBC guide is actually pretty good for looking through a lot of this. And then PyODBC, PyODBC source code has quite a bit of comments in it and information. So just stepping through that is an interesting place to go. And kind of as I mentioned, that dynamic linking, let's see, you'll see that in the setup.py file if we look for lib. And in here you can actually see things about Unix ODBC and those other ODBC libraries. So it's out there. Check it out if that seems interesting. But it's complex. There's a lot there. There's a lot of layers of abstraction, which means there's a lot of room for things to not perfectly align, whether it's between your application and the ODBC inst or ODBC.ini file, the exposure of functionality from the driver in ODBC. So that's one of the things, I guess, I kind of jumped over this and I apologize, but ODBC defines a standard for what functionality needs to be exposed. It does not create that functionality. It also, like if, for instance, with SQL Server, you have BCP, bulk copy for inserts and exploits. BCP is not part of ODBC. So if you use a SQL Server driver or free TDS that has BCP at the driver level, it knows how to do that. But because that's not something you can do with a query, it actually has to be called as kind of a function type or a method type. ODBC doesn't spec that. So if your database has functionality that can't be accessed via a query, that functionality is probably going to need to be in a database-specific library, or you're going to need to expose that somehow through like a stored proc or something else that you want to do. And that's what that loss of functionality is talking about. Most databases have something that makes them distinct. Sometimes it's their internals. Sometimes there's utilities outside of that that are also distinct, and they would not be part of that ODBC spec. So finally, quite a lot of the references that I went through to kind of dig into this and check it out, and then some additional links if you want to learn more about ODBC. But So that's what ODBC is. It's a specification for interacting with various databases and a specification for the functionality that those databases need to expose. Cross-language, cross-platform, and more than happy to answer questions. I've just kind of like, feels like there's a huge glacier here and like just kind of starting to touch on the top of that, but any questions?
So, I mean, in the stuff that I do,
Yeah.
you know, there's native drivers for the database that I use.
Mm-hmm.
Why would I choose ODBC over a native driver?
Sure.
When would that be a better solution?
So most of the time, typically you're going to have multiple types of databases. So like if you're only running Postgres, use the Postgres native driver. But if you've got multiple databases, because a lot of businesses grow kind of through acquisition or different things, and you don't always get to specify what database you're now inheriting, most databases expose an ODBC connection and driver. And so you wouldn't have to go seek out native drivers or learn new native functionality if everything you're doing is through queries. Also cross-language component. So if, you know, it's up to the vendor what language they provide a native driver interface with, right? Because most of these drivers are in something like C or C++, and then somebody might add a binding. Like the Postgres community has added a Python binding around that Postgres driver. But if that binding doesn't exist because you're either in a new language or maybe an older language, then your choice is either, do I create a binding, or most likely there's an ODBC library and driver, because those are just highly prevalent out in the wild. And instead of creating that wrapper, you can make use of ODBC, especially if what you're doing is query-based. Does that help at all?
Yes. I mean, I see this scenario.
Yeah. It doesn't sound like that's a scenario that you're experiencing.
No.
Yeah.
But I mean, even if there were, you know, multiple databases involved, there potentially could be multiple native drivers.
There could be, yes. It's up to the vendor.
Yeah.
Or a third party that wrote that for it to be. And so if you're using common languages, you're probably good to go. If you're using Fortran or something else, maybe not so much.
I mean, I'm, you know, not familiar enough with the Python ecosystem to know this, but is there a native Postgres driver and a native SQL server driver?
There are. I think you know that I'm just speaking with this generally, but
Sure.
Open source is hard sometimes. And what I mean by that is not every project has somebody behind it, and so maintaining these projects get hard, especially when it comes to projects with complexity. And what I mean is, for instance, multiple languages. So kind of off and on, I've been able to help with PyMS SQL. It for a long time was the only MS SQL native driver library, and now there's, I think, one other, maybe two. But the thing about it is, like, a lot of Python developers, especially today, have got into Python because it allows you to abstract so much of this away and just focus on your logic, right? But the free TDS driver and even Microsoft's drivers are in C. And so somebody has to create that binding and wrapper for that driver, for that functionality to be in Python, right? And if a company's not funding that or something's not driving it, it's kind of on the goodwill of open source contributors to keep up with it. And within Python, now you need somebody that knows how to use Python and C and whatever interop layers, so C-type, CFFI, or Python, as well as the free TDS spec, because you need to know what functionality is exposed by free TDS to wrap that. And so for some communities like Postgres, that's really popular. But for other databases, if a vendor's not supporting it, it can get difficult. And I mean, Case in point, PYMS SQL, we've got issues open. Free TDS has outpaced us on its release cycle and everything, and so there are bugs when interacting with different types of Unicode or different functionality. There's functionality in free TDS like BCP that doesn't exist in this Python wrapper. And so in that scenario, it's kind of, what project has the most support, is keeping up with the latest releases, is getting bug fixes fastest, things like that. And I mean, right now, PyODBC just has a lot more attention given to it than this does. So.
Yeah, the other thing is, PyODBC can be used for Microsoft SQL Server, but it can also be used for anything else that uses ODBC. So the justification for investment in that library ends up being a much larger community, and therefore gets more attention, funding. I mean, Microsoft has basically blessed PyODBC as the way to connect to Microsoft SQL Server. That's what they have developers actually contributing to that project, I think, in some shape or fashion. Whereas, PyOS SQL doesn't. So, yeah, that's I would prefer as a developer something that's just operating natively. It feels less complex to me. We're considering transitioning from PyOS SQL to PyODBC, and we've found this really kind of weird corner case when you have literals in your SQL and your order by clauses, and PyOS SQL does the right thing, and PyODBC, because it does prepared statements, doesn't do the right thing. And so that means now we have to decide if we want to kind of go with a really hacky way to get around that, or do we want to invest, $150, $300 in PyOS SQL and try to get it up to a place where it's, where it's stable again. At least that's, one of the practical realities that we're facing in a real environment.
Yep. Yeah, I mean, all of this takes time and money to maintain, right? And so if there's a company behind it or a really large open source ecosystem, like, you're good to go. If not, maybe you can contribute, but it's a series of trade-offs relative to your team, your space, and the tools and technologies.
In a secure environment, some of my experiences in Oracle and Sybase, we can do at the driver level encryption between the app and the database. Does it support that? Does the ODBC spec have encryption and decent encryption levels?
I don't know. I would check your connection strings, because my guess is going to be that would be something configured in that ODBC.ini or in that connection string space. But, I mean, and I guess it encryption where in the stack, right? Like encryption on the network or the named pipe, probably. Encryption in your application, depends on how you write it.
Yeah, it's pretty low in the stack.
The other thing is that ODBC is so well understood in the industry, sometimes it's used for an interface that's not a database on the other side. Yeah. As an example, a long time ago I worked for a company that actually used that to talk to hardware because it had SQL. So if you have a whole set of developers understanding ODBC, you want to make the hardware that you're talking to basically easy for them to understand. So because it's a standard, for the most part, it's used on there, not too much, but it can be used on there. You can write your own ODBC server, driver, interpreter.
Yeah, and to that point, the data source itself, there's two different types. So there's a store, and then there's file-based data sources that ODBC knows how to talk to both of those. So. Any other questions, comments?
So when I want to interact with some databases, I use a package called SQL Alchemy. I don't know familiar with it. Does that sit on top of this?
Yep.
Or,
Yeah, so
there's an awful lot that you went through here that has been totally hidden from you when I'm using SQL Alchemy. I don't know if this is another version of ODBC or if it's utilized.
no, so SQL Alchemy is an ORM, so it's an object relational mapper. I'm sure that's the right term. And so it's going to take your queries and your data and turn those into more like function type syntax that maybe you're used to. And so, for instance, your ORMs kind of require you to bring your own driver or connector type. And so you can see PyODBC, MXODBC, and the others there as well. So that's a layer on top of whichever package you pick there. And then that package, if you pick PyMSSQL, is going to be a native wrapper for the driver, or a wrapper for the native driver. The ODBC ones are going to be making use of this spec. Also, while we're talking about that, Python also has AIO ODBC, which is an async IO based ODBC option. If you're wanting to do some concurrency, you can mix this with the DSM level concurrency to get some pretty interesting performance. Any other questions? If you want to know more about this, I don't know. This has been super interesting for me to dig into. I don't think I have the hours to actually learn all of that spec, but if you do end up digging into it, or if you're wanting to look at some database-oriented stuff, let me know. It's always interesting.